Hello and welcome in today's online class. Today we will going to continue with the chapter dispersion and continue with the topic standard deviation. Today we are going to calculate standard deviation with next method, that is the shortcut method. In the last method, direct method, we have taken deviation from the actually calculated mean, but in this method the difference is we are going to take deviation from the assumed mean. So mean is not actually calculated but is taken from the series itself. So that is the difference between direct and shortcut method. So in individual series, x is given, we are going to arrange this x into ascending order. It's very important that we have to arrange x in ascending order. From x only, we are going to take the central value as assumed mean, like we have taken 13 as an assumed mean. Then we are going to find the deviations. Deviation is x minus a. It is always x minus actual mean or assumed mean. So in this, some deviations will be negative, some deviation will be positive. Like 10 minus 13 is minus 3. 15 minus 13 is plus 2. So we are going to total negative deviation and positive deviation separately. Then we are going to do this square of these deviation, that is d square. Then negative sign will be omitted. 3 3s are 9, 0 0s are 0, 7 7s are 49, and the sum total of deviation d square is 63. So we have two total, one is summation d and other is summation d square, and assumed mean we have taken 13 and the number of values are 5. The formula is summation d square, the last column, divided by n minus bracket summation d over n whole the square. So this d is this negative positive and this is the summation of d square. We are going to subtract d square minus summation d divided by n. And when we solve this, and we get 12 minus 6 minus 1, 11.6, and the under root of 11.6 is 3.46. So that is the standard deviation of this chapter. For this sum. Next is the discrete series. In the same way, we are going to take assumed mean from x. Like 10, 12, 14, 16, 18, we have taken a value 12 as a assumed mean. From this, frequency is given. Then we have find out the deviation, that is x minus a. Some are negative, some are positive. Then because frequency is given, so we are going to find fd. Multiply these negative positive deviation with frequency, that is fd, and their net is summation fd is equal to 50. Then next is we are going to do square of these deviation. 2 2s are 4, 2 2s are 4, 4 4s are 16, 6 6 are 36. Now we are not going to total this d square but multiply by this d square with frequency, that is fd square, and after total this column we get summation fd square, that is equal to 268. The formula will be of standard deviation, that is summation fd square divided by n minus summation fd over n whole in bracket the square, and the whole formula is under the under root. So 268 divided by summation f or n is equal to 25 minus 50 divided by 25 whole the square. So 10 minus 72 minus 4, and 6 7.2 ka under root is 2.59, that is the standard deviation or the variation of this series. For the continuous series, marks or class intervals are given, frequency is given, we have to find first midpoint, that is the requirement to solve this sum. Because x is not given, so marks will be converted as midpoints of marks, like lower limit plus upper limit divided by 2 is equal to 5. Midpoints 5, 15, 25, 35, 45, 55. Then from these midpoint we are going to take assumed mean, like we have taken 25 as assumed mean. So deviations will be taken midpoint minus assumed mean. So some deviations will be negative, like 5 minus 25 is 20, 25 minus 25 is 0, 45 minus 25 will be 20. Then we are going to multiply these deviations with frequency, that is FD. Some deviations, this answer some will be negative and some will be positive. Like 20 multiplied by 4 is minus 80, plus 20 multiplied by 3 is 60. So the summation or net of this column is summation FD is equal to 30. Now second step is square of the deviations. 20 20s are 400, 10 ka square is 100, 30 ka square is 900. Then we will multiply d square with again with frequency. 400s are 1600, 104s are 400, 902s are 1800, and the sum total of summation FD square will be 3500. So the formula is almost similar of the discrete series. Summation FD square, which is already we have done the square, divided by summation F or N minus summation FD divided by summation F whole the square. This is FD square we have already done. In this, firstly we have squared the definition, then multiply with frequency and then total. In this case, deviations directly multiply by frequency and then whole the square and under root over the whole formula. So answer we will get after calculation is 11.9, or we can write as 12. So this is about shortcut method in the continuous series. Now the next topic, which is related with the standard deviation, that is known as coefficient of variation. Coefficient of variation or CV. This method was given by Carl Pearson. According to this, it measured percentage variation in the mean, the standard deviation and the total variation of the mean. CV compares uniformity, consistency and variability in two different series. Two series are given, but we can compare their uniformity, consistency and variability. If CV is more, it is called less uniform. CV coefficient of variation is more, that means variations are more in that series. If CV is less, that means it is more consistent. CV is less, variations are CV is less, that means series is more consistent, and if CV is more, that means variations are more. But CV is always calculated from actual mean, not the assumed mean. Like in this shortcut method, we have solved the sum with assumed mean. But if we want to find CV of the same sum, we have to calculate the mean also. So for CV, formula is standard deviation divided by actual mean into 100. Same way we have to do if coefficient of standard deviation, same formula, only 100 is not there. Standard deviation divided by actual mean, not the assumed mean. You have to remember this thing very clearly. CV compare uniformity, consistency and variability. Like in this question, they have given you score of two batsmen or two individual series, you can say. individual series A, individual series B, we have to show which is more consistent. Same way this can come in any discrete or continuous series also. You can find standard deviation in any way, but mean we have to use the actual mean. Like in this series, individual series is given, we have find out the mean with direct method. Summation x divided by n, n is 10. So that comes to 46, and for B, batsman, total summation x is 50. So divided by 10, mean is equal to 50. From this mean as well as this mean, we have find out the deviations. Mean ka formula is again, that is x minus x minus actual mean, x minus actual mean. It is not the assumed mean, it is the actual mean. So deviation is 32 minus 46 is minus 14, 63 minus 36, 46 is equal to 17, whereas 60 minus 46 is equal to 14, 14 minus 46 is equal to 32. Now we have squared these deviations, and the total of these deviation is summation x square is equal to 6500. Same with the another batsman, that is 19 minus 56. 19 minus 50 is equal to 31. 31 minus 50 is minus 19. 53 minus 50 is plus 3. 67 minus 50 is 17. 62 minus 50, that's mean, is come to 12. And we have squared these deviations, and the total of these square deviation is 5968. From this we have calculated standard deviation with the direct method. Summation x square over n, that comes to 25, and here summation x square, that is 5968 divided by 10 whole the under root, answer is 24.45. If you find CV of both the batsmen, so batsman A it is 55.4, and for batsman B it is 48.6. So CV in case of batsman B is less than batsman A. So that means batsman B is more consistent because CV of batsman B is low. Right? So where CV is less, consistency is more. Variations are less, consistency is more. Variations are more, consistency is less. So here we compare the variation into different set of data along with the coefficient of variation as it suggests, and it shows the percentage. This coefficient of variation shows the percentage of the variations. So this is the chapter, the calculation part or the numerical part of the chapter dispersion. In the next video we will do, that is, graphic measurement of this dispersion, or how in a diagram we are going to measure dispersion. I hope this topic is clear to all of you.